Hi everyone, today we are going to demonstrate our full bit adder. So as you can see, this is our full bit adder design. Here, as you can see, I'll point using this wire. Here is the VCC and here is the ground. So from the VCC, we'll actually have some of these going to the switches here, and these switches will manually control which goes into the gates over here. Alright, let's start. So as you can see, we have 3 switches here that are currently in use. Each of them represent A, B and carry. So A is 1, B is 2, and 3, carry is 3. So here is the first XOR gate. So the input from A and B will go into the first XOR gate, and the output will go into the second XOR gate together with carry. So output from the second XOR gate together with the carry will go into the second AND gate. Besides the second AND gate, the first AND gate actually takes input from A and B. And both of the output from the 2 AND gates will go into this other XOR gate. Conventional designs use OR gate and not XOR gate. But because the conditions of a XOR gate and OR gate, the difference between them will never arise, so we can actually ignore the conditions and we just use a XOR gate instead. So as for the output from the second XOR gate is actually the sum, which is represented by this green wire here, and be carried over here and will be eventually outputted to this green LED. And the output from this third XOR gate over here actually represents the carry. So it will be transferred here and then will output to this yellow LED. So let me just demonstrate using the switches to manually control some of it. Okay. So this is just one of the input, and this is if A and B are together at once. So as you can see, sum goes to 0 while carry goes to 1, and if all 3 are together, you can see that both are lighting up together. And here is our brief demonstration of our full bit adder.
As for the FPGA, the finite state machine of the FPGA starts at the start state, which is indicated by this LED over here. So when I want to do manual testing, I'll push this down button and it will go into the manual testing mode. And these 3 dip switches, A, B, C, will be used for the input. So when I push A to 1, you can see that the sum LED are lit up, which means that we are correct. And when I push B to 1, you can see that the carry LED lit up and the tally, so we are correct as well. And when we do C to 1, both of them lights up. So now we'll proceed to the automatic testing. To go back to the start state, we'll press the center button, and to go to the automatic testing, we'll push the up button. And right now, here are the inputs, and here's the progress of the testing. And when the testing succeeds, you'll proceed to this LED over here. And now we know that our full bit adder works correctly.
Alright everyone, now I'm going to demonstrate to you how our full bit adder is going to catch errors. So as you can see, we have 3 red wires here. This A, B, and this is carry in. So I'm just going to do it by severing the carry in connection and then trying the automatic testing. So what I do is that I remove this wire, then I press up for automatic testing. So as you can see, it is stuck at the state of 1, 0, 0 because it has not received any input from the carry in, so it cannot proceed to the next stage. Now I'm going to plug it back in. So as you can see, it has successfully passed our test, and this is how we catch the errors. Thank you.